Welcome guys, I'm Gio here, and this is the first video in a series about functional programming in JavaScript. Why should you care about the functional programming? Well, short answer to that is that it will make your life easier as a developer. It will allow you to create more readable and therefore more maintainable code. And as you know, if your code is readable, it will make you more productive. It will make you quicker. You can quickly make changes. You can add new features quickly and so on. It has tons of benefits. On the other hand, if your code is really coupled, working with it is more painful. When you're making some change in a certain area of the project and something else breaks, and you're really frustrated. And if you look at this from company perspective as well, it costs the company money because you're spending more time working on it. So this is a short answer, personally I found that by adopting these principles and approaches that functional programming promotes, I've become more and more productive, and I've experienced those benefits myself and wanted to share my experiences with you. So even though there are many resources out there about the functional programming, many books, many theory, some videos, most of the time people concentrate on a theory, on a high level concepts, and it's good, it has a place, of course, but when you want to get started with it, maybe apply it to your day-to-day coding life, it's not very helpful. So in this series we're going to approach the functional programming in a different, very practical way. So we will take some very simple problem and try to tackle it with some functional approaches, and see, and explore a couple of concepts and see what it looks like. So then you can start using it right away into your code, into your everyday coding life, and experience those benefits yourself. And then maybe if you're interested, you can read all the books and theory and everything. But as I've said, in this series we'll focus on very practical things. So now, what's the problem that we're gonna solve? So no matter the type of application you're building, maybe you're on a mobile, creating a web-based application, browser-based application, or maybe you're working on a Node.JS, oftentimes you have to communicate with the external systems. Maybe you have to call an API, query database, parse some files from the disk, communicate with the payment service, and so on. This can go on. And most of the time you have to, the response that you're gonna get, you need to transform it so you can consume it in your application. So the fundamental problem, that everyday problem that we face as developers, is that we have some certain type of data that we need to transform it into another type of data. So we need to make this transformation, and that's exactly what we're going to do. We'll have some certain data with a certain structure, and then we'll have to transform it into something else. And first we'll try it with a traditional approach, without much of a functional programming tricks, and then we will be using functional programming techniques to achieve the same thing. And with that, I'm going to be using a library, Ramda.JS, which is one of my favorite libraries, and you can check their page. And this is very functional library in its philosophy, and really useful one. So let's jump into the code editor and write some code, solve some challenges. Alright guys, I'm going to be using a JS bin just for convenience. You can type your code in any editor you like. Just not forget to include this library in your project. It's a Ramda.JS. This is a library that we're going to use to demonstrate certain functional programming concepts. So we have here the array of video game characters, and we have to transform this array, and we want to get the array of just names. We have objects right now with each of the item in the array has name and title, and we want to just get the names. So this is a very simple example. I'm aware of that, but this can be used to demonstrate a certain concepts. Okay, so let's start with very basic example, very simple example, and how can we approach this? We're gonna do a certain number of iterations to evolve our solution and to demonstrate certain concepts. So let's start by creating some array. Let's call it transformed, and in the end we want to display this array. So let's see. Okay, it's working. And right now the very basic way to approach this problem is to use traditional for loop, the old school for loop. And okay, let's just use this. Okay, let's create some I. Let's write something like this, and let's do that. Okay, so we are doing this old school for. We have some I, and we iterate over the array, and then inside transformed we will just push each element from this data, and we will take the name. So yeah, it is working. We have used just this for loop and pushed the new items into this transformed array, and we have got the result, and it's working. It's fine. Now we can improve this a little bit, and we can move forward and evolve this code. Okay, let's comment this out so it's still there, so we can refer to it. But right now let's start our iteration too. Actually, we can go, we can make this code shorter. We can create this transformed array again, but instead of using the for loop, we can use the map function that is available on data array. We can write data map, and inside the map we need to pass in the transforming function, transforming arrow function. So for each item we will receive in this arrow function, and we just need to get the name, item.name. So, and now let's look at this, and again it's working. This is very simple, but it's already looking better. Let's look at this, and let's compare. We have first of all we have fewer lines, and it's much easier to read than this one. It's already apparent because we are just using well-defined map function, and inside we just provide our transforming function of how we want to obtain new data, and all we want right now is to get the name. So this is much better than our previous one. Okay, let's evolve our solution, and let's start using the functions from Ramda library. Okay, this will be our iteration 3, and again let's create transformed array, and right now we will be using the map function from the library itself. And here we have to specify two arguments. First one is the transforming function, transforming arrow function, that should be used for every item inside the array, and this function will stay the same. We will get the name, and the last argument here is the data that we want to transform, is the list we want to transform. In our case, this is our data array. So let's clear this, run again, and it is just working. Now, it's not necessarily better than the previous version. We have just rearranged things, and you might have noticed, and it might feel a bit weird for you to specify this data last, but we will see why it is that way soon. So we have started using these functions, this function from library. Okay, now let's move forward, and let's evolve our solution a little bit and let's get familiar with this library. So here, if we see, even though it's a very simple example, this is a simple example, we have several things going on here. We have this item here, we have this transforming function that is applied for every element in our array. And then we have this operation of getting the name, of getting this name from the given object, from given item. Actually, there is a function inside this library, inside Ramda, that defines this operation. Okay, let's comment this out and create another version. Let's use the map again, pass in data, and inside we have as a first argument we have this arrow function again, but instead of directly accessing this name property, let's use some function from Ramda library that will help us to do that. So we have this prop function, and here first we specify what property we want to take, and it is a name, and then we specify the object that we want to take this property from. In this case it will be item. Okay, let's clear this, run again, and we have got this. And you might wonder, why do we ever need to use a function to get this name, to get this property, get name property? We can just use this item.name. What's the point? And we will see that soon. But before we move further, and make improvements to our code, let's make one key observation here, and keep this in mind, this observation. On every step of the iteration, the fact that we need to take the name stays the same. The only thing that changes is the given item. So the fact that the operation that we want to take the name is constant, and we are just changing the object that we want to take this name from. Just keep this observation in mind. Okay, let's evolve our solution a little bit and move to iteration number 5. First, I want to do some experiment and make some observations about this prop function. Okay, let's create this transformed variable and let's write something like this: prop, not the prop but the name, and let's take the name from this object. How do you think? What's the result of this call is going to be? Just pause the video and guess what the result's going to be. It's going to be just a name. If we just put this another object, it will be another name. Alright, now let's do something else. Okay, instead of just specifying both arguments here, let's specify only one. Let's specify the name. Let's just put in the name. Now what do you think the result of this call is going to be? And this is a really key moment. Just pause the video and think, just to check your assumptions. So what's this result is going to be? Okay, let's check this. And here we see that this is a function, but how is it? It's a bit weird. Usually when you do not pass necessary amount of arguments to the function, maybe it will throw some error or return some undefined or some unexpected result happens. But here we have got the function. What's this function? What this function is all about? What is this transform thing here? And well, let's test this. Let's pass in something. Let's pass in some object to this function. To this transformed function. Okay, let's pass in this and see how it will go. Oh, as you see, it returned the name of the given object. So what really happened there? It kind of appears that this function, this new generated function, knew somehow that it should have taken the name from given object, and that is the case. So when we specified only one argument for prop function, it generated a new function which in turn remembered, that the name should have been taken from the given object. So this technique is called carrying, or partial application, if you will, and all the functions in this library, in this Ramda library, are carried, meaning that we can effectively manage the inputs of our functions, and we can generate new functions from already existing functions. In this case, we have just generated a new function that will get the name from given object. Let's rename this and call getName, and now we can use this getName function to retrieve name from any object. Let's clear this, run again. Alright, we've got this. Let's pass in another object and see how it goes. Alright, so we have generated a new function. So the underlying logic is the same of this prop function, but until all the arguments are specified, this function won't execute its logic. Instead, it's going to return the new functions, new generated functions. And that is good because we can generate new functions from already existing functions and then compose them. And that is a quality that we want to have in our software when we're writing some programs. Now as we have this getName function, let's use this function. Let's use that into our transformed to form our transformed array. Let's log transformed here, and now let's use this map. Let's pass in some data here, and in the arrow function that we are using, we can pass getName item. Okay, and here again we have got the list of our characters, the list of their names. Okay, let's move forward and make a certain improvements. Let's do our iteration number 6, and let's again create this function getName. I'll just repeat myself for demonstration. We have this getName function, and here if we look at this closely, in our arrow function, we are just creating this arrow function, getting this item, and then passing it to getName function itself. So this whole expression seems unnecessary to me, since getName already itself expects this item. We can just put getName here instead of this arrow function. So here we can write something like this. I'm gonna copy this, and instead, we're gonna pass in the data, of course, and instead of our custom, our own arrow function, I'm gonna pass in getName here. And as you see, let's clear this, run again, and it is working just fine. Now let's make our final improvement, another improvement, and then talk a bit about this, techniques and these functions, and why this why this solution is better than our original one. So let's create our iteration number 7. I'm gonna again just copy this, and now I have a question for you again. What if instead of passing these 2 arguments here, I'm gonna pass in the getName function only? What's the result is going to be? What's going to be in this transformed variable? I hope you already guessed it. It will be a function. It will just be a function. And when we provide the final argument to this map function, to this transformed, and if we pass in the data, we will just get this transformed data, just getting the list of names. So, as it was the case with the prop function, the same is with map, and almost all the functions, as I've mentioned before, are carried in Ramda library, and we can use this property to generate new functions. So let's call this function extract names, and let's create this, transformed, and instead of just using this whole map expression, we will just use extract names, and here we are going to pass in data, and we will just log this transformed variable. Okay, let's run this. And again, we know we have got the list of our video game characters. Okay, now let's think about this solution, our final solution, and think why it is better than our previous one, our first one, why it is necessarily a better approach. So I think the first and the obvious benefit of this approach is that we have separated our operations, our actions, from the actual data itself. So we have taken the problem, even though it's simple, and we have created very small sub-problems for our problem and created solutions for them. For example, this get name, even though I understand it's very simple. And then we have composed this, our functions to generate new functions. And that way we have defined our operations. And it is separated from this given data. This can be reused, this extract names function can be used with any array. While in this case, in our first example, this solution was tied to this transformed array, it was tied to our data, it was tied to this variable, this iteration variable, and there was a lot of coupling going on. While in this case, I can easily move parts. This get name is separate from the rest of the code. Extract names is just a function that is reusing already existing functions, map and our generated get name function. And here we achieve composition and we get the names. Now I can change this, I can call it a result, and it will just work without anything else, because this logic of extracting names is separated. I can even, let's say, have another list, let's call it data1, and I can use this data1, and here I'm gonna get the name of movies instead of characters. And I think that is the great benefit of this approach, because we have achieved reusability on a functional level, and this library helped us with that. And let's reiterate what we have done. We have used technique carrying or partial application to partially apply arguments to the functions and generate new functions from already existing functions. Then we have used composition to again generate new functions, in this case extract names, and we have, by following this, we have separated our operations from our data, and thus we have achieved reusability on a very tiny, very small level, on a very small scale, on a functional level. And I think this is a great achievement, because even though this is a simple example, the benefits are apparent even there. And now imagine applying these principles on a scale when you have like 3 million lines of code, and you have to manage parts carefully. Now we can move this around, we can reuse them in other parts. So even though we have just covered two functions, prop and map, there are many functions inside this library, and we can achieve many more interesting transformations. So we're going to be covering all of that, not all the functions, but many functions in future series, and we're going to be exploring more this type of programming. And now probably I've already answered the question why we are specifying in this Ramda functions our data last, because that is in its core philosophy of the library itself. So first we define our operations, we break down our problem into very small, tiny problems, create solutions for them, and then assemble them into our final solution. And then, when the time comes, we use these operations on any data we want. So, hope you enjoyed. Click the like button, subscribe, and share it with your friends.